Now we're going to take a look at the binary search. Binary search. We'll start out by just taking a look at the overall concept. So let's say we had an array, and this array was already sorted. So we draw it out like that, and it's already sorted, which means we're going to have our index values. So these index values have nothing to do with the actual sorted information. They are just say, what position is which. Probably should have started at 0. So there we go. And then inside of here, we would have some values. And these values are clearly going to be sorted, right? So these are going to be in order. You can have 200, 250, and then, so on and so on and so on. I'm not going to write them all out. We'll have like 1,000 over here. So we know what all these values are, and they are all going to be sorted. So how long will it take to find a value? We know how the binary search works. It's going to go ahead and it's going to find the halfway point. So I don't even know how many cells I drew here, but let's just say that the halfway point is here. And it's going to say, is your value to the left? Is it to the right? Or is it right underneath? And you picked it out. And then it's going to say, okay, if it was to the right, we are going to go over here. We're going to pick the new halfway mark, and we're going to look to the left, we'll look to the right, and we'll look to where we actually are and see which way we would need to move. So how long will it take you to arrive here, right? Every time you do a binary search or one of the loops of the search, you are going to be looking at a smaller portion of information. You'll go from looking at all the information to looking at half the information to looking at a half of that information until you arrive where you need to be. So let's take a look here. Let's say that this array, and we have position n over 2. Let's say this will be the key in the middle of the array. And let's say that would be 43, right? Pick a random number, and that's going to be 43. Now we'll go right to the middle, and we're going to take the floor of that number, right? So that means we are going to essentially just cut off any decimal place and just look at the real value. So let's say the number was, 43.7. We are going to cut that off, and we are just going to go to 43. No rounding, right? It needs to be the exact same thing each time. So we're going to arrive at that middle number, and we are going to say that if the array n over 2, the floor of n over 2, is less than k, the key that we are going to be looking for, then we will call recursion on the right hand side. So if the key that we want is going to be greater than, or essentially if the middle value that we find is less than the key we're looking for, that must mean that the key is going to be bigger than that value, and thus since the array is sorted, it's going to be on the right side, right? Look here. If the key we want is over here, somewhere hidden here, we're going to start off by going in and cutting down the middle. We'll check left. No, it can't be there. We'll check right. Oh, yeah, it can be there. And we're going to go ahead and cut here and then do the same search looking both ways. And thus, on the other end, right, if, to just complete what we had started writing before, if the array value floor of n over 2 is going to be greater than k, then call recursion on the left-hand side. On the left-hand side of, or not the equation. I'm thinking of math. Sorry here. Of the array. There we go. So that would be how we are going to do it. So let's go ahead and just do like another simulation of this, right? Just a brief one. Can only have so many pictures I draw, and then it eventually just starts being, extremely redundant. So this is our array, right? This is our array of values. I'll cut them up to a few cells over here. Horrible picture, absolutely atrocious, just awful drawing. And we'll start off over here, right? The first one will go to position n over 2. And let's say that we see that this value that we found, the key at this index, the actual numerical value that's being stored here, is going to be less than k, whatever we're looking for. So let's actually go ahead and say that this value in the middle is 20, and we are looking for some key over here, which is the 43. So it's okay. Now we're going to have to go ahead and we're going to call this recursion on this side of the equation, right? Call recursion on the right-hand side. So we will divide that right-hand side in 2. So now this position is going to be n over 2 plus n over 2. It's essentially going to be the position where we're calling it. And then once again, we'll see that we'll need to do on this side, and we'll cut it again. We'll keep cutting until we land on the key we want. So that's how the binary search works. This is a, really just messy way of looking at this, right? We'll take a look at the algorithm, and more specifically, we're going to take a look at the runtime of the binary search in the next video. I don't want this to run on too long, but this is the concept behind the binary search, right? And you can think about this as if you were looking in a dictionary, right? If you're looking in a dictionary, you want the word, I want to think of a word that's, somewhere in the middle of the alphabet, but I just suddenly can't think of one. We're going to be taking a little look at the binary search algorithm. And remember, this series where we're going to be looking at the binary search algorithm. So binary search. In this video, we're just going to be taking a look at the concept behind the binary search. So just simply, what is it, right? So we're going to have an array, and this array is going to be sorted. So we have this, long box that's going to contain all these numbers. So let's go ahead and make some spaces in here. Try to make this look nice. My previous attempt at recording this, my array just looked so ugly that I couldn't, live with myself. So we're going to have our indexes, right? So I'm just gonna go ahead and start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and I should have, I guess, a 0 over here. So there we go. So we have our array set up like this. Now, those values we see down there are just, they don't really have any purpose, right? They're just the indexes, and they're not really going to affect what we're doing right now. We want the keys. We want the actual keys. And those keys are going to be the values that we see inside of these cells. So these are going to be the numerical values, and these can be anything. And these are sorted, right? So these are going to have to be in ascending order. So 4, 5, 7, put 11, I can put 20, I can put 100, I can put 111, 112, 131. I'm trying to find numbers that can fit. 141, 200, 300, 400, 900, 1000, 1001. I can fit it in, and I'll put 1200. So we have all our values in there, and this is a sorted array. So sorted. It needs to be sorted. So we have all those numbers that are there, and we want to find a particular value in this array, or we not want to find it, we want to see if the value is inside of the array. So let's say I want to find the value. What's a number we want to pick? Let's pick a number that's actually inside of here. We'll pick the number 900. We want to see if the value 900 is going to be inside of this. Now we're going to use essentially the approach that we would if we were looking for a word in the dictionary. So let's go ahead. And we have a dictionary, right? We've used plenty of dictionaries before. You probably have not used one since you have decided to go on a path of computer science. It's really not, haven't had to write much essays, I would imagine, at least, especially with the internet. We don't really need to look things up in the dictionary anymore, but you might have an English class, and I'm sure you at least know how a dictionary works, right? So here's a poorly drawn dictionary. And when you want to look up a word in the dictionary, what do? Well, you're going to start off by opening it up. And let's say you open it up right in the middle. And the word that we want, let's say, what's a word that we're looking for? Let's look for the word banana, right? So we're looking for the word banana. And you're going to have this, let's just think of this as your dictionary, right? You have the words from A all the way to Z. I think aardvark is the first word, and I don't really know what the last word in the dictionary is. But you can open this up right in the middle, right? And let's say you open it up and it's just one page in the middle. What do you see? Well, let's actually say we're in the M's and we actually come up on the word middle. So that's going to be the word at the top of the page when we look at it. Well, where is the word banana on here, right? Relatively, we know the word banana is going to be somewhere around here, right? In the B's. So B, banana, is going to be somewhere here. Okay, whatever. So it's going to be somewhere there. Well, if we open it up and we see middle, we know that it's going to be in this direction. So we are going to go ahead and we are going to cut in the middle between A and M here, and we are going to do our assessment again. Well, let's say we come across the word elephant here, right? Elephant. We're in the E's. Well, we know we still need to keep going, right? So we're going to keep going again, and we're going to cut once again in the middle for the remaining room that we have. Trying to get some nice magenta going on over here. And we'll cut over here, and let's say we are in the C's and we have the word cat. So we know we have to keep going again, right? So we keep going this way, and let's say we cut again and we arrive right over here. And we're now on the wrong side, and we have the word bandit. Well, that means we've gone too far, and now we are going to be working in that direction slowly, until we arrive on our word, right? We'll find out we're going to arrive right on that word if it exists. If it doesn't exist, then we just return false, right? True, if we find it, it is inside this section, or this, this information that we have, it's inside there, or false if it's not. So that's essentially the strategy behind that. And my dictionary, I can make it look a little nicer with, some things. Like some dictionaries even have pictures. Well, I don't know. My dictionary has pictures in them. So that's the basic strategy we're using with a binary search. Now we want to find if the number 900 is inside of this sorted array. So we are going to go ahead and we are going to look for position n over 2, the floor of position n over 2. Well, we have, I probably should have just kept this starting at 1 here. It would make more sense. Anyways, that's irrelevant right now. So we want to look for position n over 2 because that's going to be the halfway mark. Well, we have 18 cells over here. So the halfway mark is going to be this position 9 over here. So this position 9 is where we are going to start. We're going to put a flag over here, and we're going to decide, do we need to move to the left or do we need to move to the right? Now, right now we know that our index that we have n over 2 is less than the key that we want, right? It's less than it. We want something that's going to be 900, and we found the value over here, which corresponds to, actually I should write, the array right there. So that's, you're passing that index into the array, so this will get you the value of 311, which is less than 900, which means we need to be looking in the right direction. So we need to go up a bit. And we're going to go up a bit, and we are going to say we have the values 10 to 17 now. So 1, 2, 3, 4, 5, 6, 7, 8. What is the middle value? The floor of the middle value is going to be right over here. So we're going to set another flag, and we're going to say, do we need to move to the left or do we need to move to the right? Well, 400 is still less than 900, which means we are going to need to move to the right. And if in case you were wondering, this position over here, it's going to be half of the half, right? So this position is going to be n over 2 plus n over 2, right? So that corresponds to that. We keep that pattern going as we move around, and we're going to move again to the right. So we have 1, 2, 3, 4. So we're going to take the floor over here. We'll put a flag right here. And now we know that 1,000 is now going to be greater than 900, which means we have passed the value which we want, or at least the space where our value could be. We never said it is actually in this array. And then we're going to use the area between the last flag we had and the current flag, which in this case is only going to be 1. And now we have arrived on 900, which means we will return true. our value is inside of the array. Well, this was a bit of a messy. I didn't mean for it to get this messy, but I'm sure you guys get the general idea of the binary search. It's essentially going to be a dictionary. You open up your dictionary in the middle, you determine if you need to go towards the start of the book or towards the end of the book to reach your word. Then you will cut the remaining area in half, and you'll keep cutting in half until you find the value you want. Now we're going to be taking a look at the runtime of the binary search algorithm in the next video, which is going to be a little bit more interesting. So I'll see you guys then.